On November 21st, 2021, the Parker Solar Probe came really close to the Sun, just 1.5 million kilometers away. It was the closest any probe has been to our star, and it became the first probe to touch the Sun's outer layer, called the corona. But why did it have to face so many technical difficulties to get that close? What was Parker trying to find by getting near a place where everything turns into ash? To understand this, let's look at what we already know about our system's star. The Sun is a main sequence star, about 4.6 billion years old. It's a typical yellow dwarf, falling into spectral class G2V. The Sun's surface temperature is about 5,800 Kelvin, which is 5,530 degrees Celsius, but there are both colder and hotter areas on it. Interestingly, the star's inner layers and its outer corona are extremely hot, reaching millions of degrees, but they contribute very little to the visible radiation. The Sun's average diameter is around 1.4 million kilometers, which is 109 times that of our Earth. In terms of mass, it's a massive 2 × 10 to the power of 30 kilograms, or 333,000 times that of Earth. In fact, the Sun makes up 99.9% of the total mass of the entire solar system. So, by getting up close, the Parker Solar Probe aims to learn more about these extreme conditions and expand our knowledge of our Sun. We usually see the Sun as small, but it's actually larger and brighter than 80% of all the stars we know in our galaxy. Most of the Sun is made up of hydrogen, about 92% of its overall volume. In a previous video about stellar evolution, we talked about how this gas fuels thermonuclear reactions in stars. When the temperature gets really high, hydrogen nuclei merge, releasing a lot of energy and turning into helium. Currently, helium makes up 7% of the Sun's volume and 25% of its overall mass. Besides helium, the Sun contains other elements like carbon, oxygen, nitrogen, and iron, but they make up a small percentage. The Sun has a complex structure with different layers. At the center is a massive core, making up 25% of the Sun's overall size. The core is super hot, around 14 million Kelvin, and each cubic meter of material weighs about 150 tons. In the core, thermonuclear reactions happen, producing the energy that makes our Sun shine. Every second, about 4.26 million tons of stellar matter is transformed into luminosity. Surrounding the core is the radiation zone, extending up to 0.7 times the Sun's radius. In this part of the star, the matter is very dense, making it hard for it to mix thoroughly and carry heat to the upper layers. Instead, energy is transferred by stellar plasma particles, absorbing and radiating photons continuously. Mathematical modeling shows that the temperature in this part changes dramatically from 7 million Kelvin deep inside to 2 million Kelvin on the outer boundary. A quantum of light produced by the core may stay in this radiation zone for 10,000 to 170,000 years before moving on to the next layer, known as the convection zone. The convection zone is the outermost layer of the Sun, and the stellar matter here is less dense and more changeable. This leads to huge vortices, carrying hot plasma from deeper regions to the Sun's surface. These vortices remain stable for 10 to 15 minutes before getting destroyed and giving rise to new ones. This continuous movement of matter creates a magnetic field that spreads throughout the inner part of the solar system. The Sun also has an atmosphere with several layers. The lowest one is called the photosphere, emitting most of the visible light we see from the Sun. It's about 100 to 400 kilometers thick, with temperatures ranging from 6,600 to 4,400 Kelvin. Above it is the chromosphere, around 2,000 kilometers thick, which can be seen during a total solar eclipse or with special equipment. The chromosphere is extremely hot, with temperatures fluctuating between 4,000 Kelvin and 20,000 Kelvin. Interestingly, the outer border of the Sun is covered with continuously active jets of hot gas called specules, shooting up a staggering 5,000 to 10,000 kilometers high. The topmost part of the Sun's atmosphere is called the corona, consisting of giant prominences, flares, and emissions that can reach sizes of 1 million kilometers. The matter in the corona is very sparse and incredibly hot, with an average temperature of 1 to 2 million Kelvin and peaking at 20 million Kelvin. This area is sometimes crossed by the Parker probe, which dives deeper and deeper into the blazing abyss. Calculations show that the energy released by the photosphere is not enough to heat the chromosphere and corona to such high temperatures. This means there are still undiscovered physical phenomena in the Sun that contribute to the heat in the upper layers. There are scientific hypotheses to explain this thermal paradox. One suggests that the chromosphere and corona gain extra energy from reversing magnetic shock waves. Another idea involves the acceleration of charged particles in the Sun's powerful magnetic field. The Parker Solar Probe was specifically designed to investigate these phenomena and study obscure processes in the upper layers of the Sun's atmosphere. It is part of NASA's project known as the Parker Solar Probe, launched in 2009 and took off from Earth on August 12, 2018, for its one-way journey to the Sun to fulfill its mission. Before reaching its destination, the Parker probe had to perform several maneuvers to enter the desired orbit. By using Venus's gravity, Parker carefully adjusted its path, getting closer to the scorching ball at the center of our solar system. The probe was well prepared for the Sun's intense heat, equipped with a heat shield and gear designed for extreme conditions. Parker's orbit is planned to take it close to the Sun for a short time before moving away, allowing it to release heat into space and avoid prolonged exposure. The main goal of the probe is to study the structure and dynamics of the Sun's magnetic fields in its immediate vicinity. Additionally, Parker aims to measure the energy emitted by the Sun, capture particles from the stellar wind, and record wave-like processes in the Sun's corona. As a side mission, the probe took photos of Venus and a nearby comet as it approached the Sun. To achieve these objectives, the probe is equipped with various scientific instruments such as cameras, particle capture tools, magnetometers, and radiation detectors. Despite facing challenges like critical temperatures and exposure to powerful ionizing radiation, the Parker probe continues its mission. Transmitting the collected data back to Earth is also a challenge due to the Sun's interference in the microwave range. Nevertheless, the Parker probe persists in its mission, shortening the distance to the star with each completed orbit. In late February 2022, the Parker probe will pass through the Sun's corona once again to collect more data. By 2024, the distance between the probe and the Sun's surface will be the shortest ever, just 6.5 million kilometers. Estimates suggest that during its closest approach, the solar shield of the probe may heat up to 1,370 degrees Celsius, which is 3 times hotter than the sunny side of Mercury and slightly lower than the melting point of iron. Currently, the probe is speeding at 163 kilometers per second during its closest approach, but it will eventually accelerate to 200 kilometers per second, making it the fastest human-made object in space. The probe's life expectancy isn't very long. Once it reaches the closest point to the Sun, Parker will complete several orbits, which is expected to take about a year. During this time, it will lose speed, and its scientific instruments will be exposed to extreme temperatures and powerful radiation. Eventually, they will stop working, and the probe will descend into the sun's scorching depths, swallowed up by the blazing plasma. Before that happens, Parker will send back significant amounts of useful data to Earth, helping us advance in space exploration. This proves that Parker's journey is not in vain. Mercury, though relatively close to Earth, has been challenging to explore due to its proximity to the Sun. It can only be observed at the horizon shortly before sunrise or immediately after sunset. Ancient astronomers even thought Mercury was two different celestial bodies. Thanks to advancements in observation equipment, scientists have gradually uncovered some mysteries of this unusual world. The data gathered reveals that Mercury is the smallest planet in the solar system, even smaller than some moons. Its radius is 2,440 kilometers, roughly 38% of Earth's size. Despite its small size, Mercury has a surprisingly large mass, equal to 3.33 times 10 to the power of 23 kilograms, about 5.5% of Earth's mass. Mercury's shape is almost perfectly round, with a minimal difference of less than 1 kilometer between its equatorial and polar diameters. Comparing Mercury to objects of similar size, it is heavier than Ganymede and Titan combined, even though both have larger diameters. This is likely because Mercury has a massive metallic core with a radius of about 2,000 kilometers, accounting for 57% of the planet's volume. The core is surrounded by a 400-kilometer layer of mantle composed of molten silicate rocks, and the mantle is covered by a hard crust that is 15 to 37 kilometers thick. The surface of Mercury is marked with numerous craters, indicating that the planet has not been geologically active for the past 3.8 billion years. Observing Mercury through a telescope was challenging due to bright sunlight until the second half of the 20th century. In 1974, the Mariner 10 space probe changed everything by reaching Mercury's vicinity. It captured pictures of 45% of the planet's surface, measured its temperature, and studied its magnetic field. Additionally, the probe's sensors detected the very thin atmosphere composed of helium and other gases. 30 years later, on August 3, 2004, another spacecraft named Messenger launched from Earth. It took a long 11 years to reach its target, but the little probe successfully faced all challenges and completed its mission. From 2011 to 2015, Messenger sent back hundreds of thousands of images for scientists to study, providing a nearly complete view of Mercury's surface. These pictures yielded essential data about the planet's inner composition and various features of its terrain, some of which are unique in the solar system. Messenger's sensors also provided valuable insights into solar wind and its unusual interaction with Mercury's magnetosphere. Mercury follows an elongated elliptical orbit around the Sun, taking 88 days to complete one orbit. In its perihelium, the planet comes very close to the Sun at 0.31 astronomical units, while in the aphelium, the distance is 1.5 times larger at 0.47 astronomical units. Mercury's unique orbital resonance is of special interest. Its stellar day is 58.65 Earth days, which is 2/3 of a Mercurian year. This causes the planet to alternately face the Sun with one side and then the other during its orbit. The regions facing the Sun most directly during perihelium are called hot meridians. One such region features the largest geological formation on Mercury, known on maps as Coloris Planitia. The name Coloris Planitia, translated as a heated plain, is entirely fitting because temperatures here soar to 700 Kelvin or 427 degrees Celsius, making it the hottest spot on Mercury. This plain is a massive impact crater, measuring 1,550 kilometers and covering about 2% of Mercury's total area. Estimates suggest that the crater formed around 3.9 billion years ago, when a large asteroid, about 100 meters in diameter, collided with the young and hot protoplanet Mercury. The impact would have destroyed a significant part of the barely solidified crust, causing molten lava to spill over a vast area of the planet's surface. When it cooled and solidified, the plain was shaped by a rocky crust, appearing as a bright spot against the dark valleys surrounding it. The surface of Coloris Planitia is filled with numerous craters, some measuring up to 100 kilometers in diameter. However, the most remarkable feature on this plain is Pantheon Phocae, a unique structure in the solar system. This formation is created by a radial set of 230 troughs or extension faults, ranging in width from 1 to 8 kilometers. Most of the troughs are less than 175 kilometers in length, with some extending even further. Near Pantheon Phocai's central point, there is a relatively large crater called Apollodorus, but it's unclear if it has any connection to the troughs. There are several hypotheses about how Pantheon Phocae formed. One suggests giant cracks due to tectonic activity, while another points to the planet's cooling process. Coloris Planitia is a bright and light-filled area, but as we move slightly north, we find a land of ice and darkness. Mercury's axis has a tiny tilt, so its polar regions are always in dusk. The sun either hangs on the horizon or doesn't appear at all, leaving some crater bottoms untouched by sunlight for millions of years. Borealis Planitia, around the North Pole, is the coldest region, with temperatures around 80 Kelvin, or 193 degrees Celsius below zero. Water ice deposits, up to 2 meters thick, have been found here in the shade of mountain ridges covered by rocky dust to prevent evaporation. Some elevated areas catching sunlight can get as hot as 380 Kelvin or 107 degrees Celsius. Interestingly, these contrasting areas may be close, but Mercury's thin atmosphere limits effective heat exchange, maintaining a stark temperature difference. Moving to more southern latitudes, practically on the same parallel as Coloris Planitia, but 3,500 kilometers to the west, we find one of Mercury's largest craters, Rachmaninoff. It has a diameter of up to 290 kilometers and is approximately 1 billion years old. In the center of Mercury, there's a tall peak ring formed by mountain peaks, about 130 kilometers in diameter. The rocks here have a reddish hue, and you can see signs of solidified streams on the surface. This structure is thought to be of volcanic origin, marking one of the planet's recent volcanic activities. It's also the lowest point on Mercury's surface, measuring minus 5,380 meters relative to the planet's average. Beyond the central ring, there are smooth and dark areas. Moving south, there's a huge escarpment called Enterprise Rupes, stretching 820 kilometers from southwest to northeast. In some places, it reaches heights of several thousand meters. Enterprise Rupes is the largest escarpment on Mercury. These unique terrain features are believed to have formed as the planet cooled, causing it to slightly shrink and lose about 1% in volume. This deformation led to the creation of gigantic cliffs. Almost half of Enterprise Rupes is within Mercury's largest crater, Rembrandt, with a diameter of 716 kilometers. The wide basin of Rembrandt contains various relief features, including small mountain ridges running from the outer ring to the center, with widths ranging from 1 to 10 kilometers and lengths up to 180 kilometers. Another ridge forms a ring about 450 kilometers in diameter. On the crater's bottom, an intricate pattern of deep cracks resembling a spiderweb can be seen. Scientists believe that conducting more detailed studies of the rocks on the crater's surface will help us better understand Mercury's inner structure and the processes happening inside it. Despite astronomers closely examining Mercury and advancements in observation equipment, the planet remains mysterious and largely unexplored. However, exploration of Mercury is underway, with the Colombo spacecraft rapidly approaching. This joint project of the European Space Agency and Japan aims to collect data on Mercury's surface and atmosphere composition, study its magnetosphere and solar wind, and update information on its relief features. Although Bepi Colombo has passed Mercury before, there are still maneuvers to perform to slow down and enter an operational orbit around the planet, expected to be completed by 2025. Venus, the Sun's second closest planet, is located 0.72 astronomical units away from the solar system's center. Its orbital period is approximately 225 Earth days, and every 584 days, the distance between Venus and Earth shrinks to around 0.25 astronomical units during their closest approach. Interestingly, Venus always presents the same side to Earth during these close encounters. The reason for this is not definitively known, but it could be due to tidal forces from Earth, or simply a coincidence. Physically, Venus shares many characteristics with Earth. It has an average radius of 6,052 kilometers, about 95% that of Earth, and a mass of 4.87 times 10 to the power of 24 kilograms, which is 0.82 times that of Earth. Venus completes a full rotation on its axis every 243 days, with a rotation axis tilted at 3.4 degrees with respect to the ecliptic plane. For a long time, Venus has hidden its true face behind a dense atmosphere and thick clouds, making it challenging for observers on Earth to study. This led to a variety of imaginative ideas and theories. Some suggested there might be an advanced civilization hidden under Venus's tough outer layer, while others thought it might harbor unique life forms until relatively recently. However, assumptions about Venus remained in the realm of imagination until space flights and advancements in radiolocation technologies provided a breakthrough. For instance, scientists discovered that certain radio waves could pass through Venus's atmosphere and reflect off solid rocks. This discovery allowed the creation of the first maps of Venus in 1978 by the orbiter pioneer Venus 1, with contributions from Soviet orbiters. However, these maps had limited accuracy, prompting the launch of the Magellan orbiter from 1990 to 1994. The Magellan spacecraft beamed back images covering 95% of the planet's surface with a remarkable resolution of 120 meters, making it the most comprehensive and accurate data about Venus's surface. Before delving into a planet's surface, understanding its inner structure is essential. According to the most reliable theory, Venus has a metallic core at its center, comprising 25% of the planet's overall mass. Despite having no magnetic field, observations suggest the metallic core is likely in a solid state, surrounded by a silicate mantle extending 3,000 kilometers deep. A solid crust with an average thickness of 16 kilometers tops the mantle. Venus's lithosphere doesn't form tectonic plates due to high temperatures and rock viscosity, resulting in geological activity different from Earth. Additionally, Venus is distinct for its scarcity of large impact craters. Large parts of Venus's surface are covered by basalt plains formed from solidified lava. Some unique Venusian features, not seen on other planets in the solar system, include tesserae, highly rugged mountainous areas resembling roof tiles. Arachnoids and coronae are two other distinctive types of Venus's terrain, featuring circular structures with diameters measuring several hundred kilometers. Although they might seem like impact craters, these formations originated from tectonic processes rather than celestial objects. For an untrained eye, Venus's terrain features may not be easily noticeable, even in processed images. To better understand, let's explore the elevation map of the planet's surface, where areas of different heights are highlighted with contrasting colors. The most prominent elevated feature on Venus is Aphrodite Terra, often considered a hypothetical continent. Stretching along the equator, Aphrodite Terra's mountainous relief is complex, with an estimated length of up to 18,000 kilometers and a width around 5,000 kilometers. Depending on how the continent's borders are defined, its area is estimated between 29 and 41 million square kilometers, comparable to Asia's size. Aphrodite Terra is divided into three vast regions: Alpha Regio, Beta Regio, and Gamma Regio. Alpha Regio, located in the eastern part, stands out for hosting Venus's highest volcano. The distance from its base to its summit is approximately 5 kilometers, with an overall height above the average surface level ranging from 8.3 to 8.8 kilometers. According to various estimates, the volcano is currently not active, although there is evidence suggesting it erupted relatively recently in geological terms. This evidence includes solidified lava flows and the absence of impact craters. The volcano, located on the slopes of Beta Regio in the western part of Aphrodite Terra, is particularly interesting due to its tectonic activity. The mountain ridges in this region run in different directions, indicating various forces acting on the crust simultaneously. Additionally, deep crevices containing traces of lava spillage have been discovered, making these among the most unusual volcanoes on Venus. Moving to the western edge of Aphrodite Terra, we find the alleged landing sites of 4 Venera probes. 2 of these probes were destroyed by the planet's atmosphere before reaching the surface. These sites are situated in the southern part of a vast lowland region known as Guinevere Planitia, which extends for thousands of kilometers, comparable in size to Aphrodite Terra. Despite being called a planitia, this area has diverse relief, including various geological formations. Tectonic forces crumpled the planet's crust for hundreds of millions of years, creating ridges and folds. Meanwhile, lava spilled from crevices, solidifying to form smooth basalt plains in the lowlands. As a result, Guinevere Planitia features both flat areas and distinct uplands. The western part of Guinevere Planitia borders Beta Regio, a bright and elevated area with a round shape, approximately 2,500 kilometers in diameter. The eastern part of Ishtar Terra is the resting place of the remains of the Venera 9 and Venera 10 spacecraft. These spacecraft provided us with the first photos of Venus in 1975, measured the atmosphere's properties, and collected soil samples similar to basalts on Earth. This data suggests that Beta Regio is Venus's largest volcanic massif, making it a promising area to search for active volcanoes. Moving northward, we reach the second largest hypothetical continent on Venus, called Ishtar Terra. It spans about 8,000 kilometers from east to west and approximately 2,500 kilometers from north to south, with a total area of around 8.5 million square kilometers, just slightly larger than Australia. In the center of Ishtar Terra lies the largest volcanic massif on Venus, Maxwell Montes, towering 11 kilometers above the planet's average surface level and 7 kilometers above the surrounding terrain. Maxwell Montes features a relatively flat plateau of approximately 200 by 400 kilometers around the highest peak. The height difference within this region is minimal, making it challenging to distinguish individual peaks accurately. Maxwell Montes is the coldest area on Venus, with temperatures around 380 degrees Celsius, and the atmosphere is about twice as rarefied as near the surface. Despite the harsh conditions, the region appears bright in photos, suggesting that the peaks and slopes may be covered with a reflective substance. Many parts of Venus's surface may be covered with metallic compounds containing impurities like pyrite, hematite, or galena. Exposed to high temperatures, these substances can vaporize from lowlands and then precipitate in colder mountainous regions, resembling fine-grained snow. As we explore the Venusian surface, the thought of these incredible and mysterious places remaining unexplored by humans comes to mind. Is there a chance for us to leave our footprints on this planet's surface, so close yet so forbidding? The atmospheric pressure on Venus is about 93 times that of Earth, and the average temperature near the surface is a scorching 737 Kelvin or 464 degrees Celsius. These extreme conditions make it challenging for space probes designed for Venus exploration, lasting no more than an hour. The idea of terraforming Venus seems unrealistic due to its harsh conditions. However, in the upper layers of Venus's atmosphere, there are some regions with temperatures and pressures closer to those of Earth. In the last century, there were even ideas about designing a habitable base floating in Venus's atmosphere, suspended from special aerostats. Yet, the practicality of implementing such projects remains uncertain. Whether or not humans will set foot on Venus, the planet awaits its heroes, and its secrets will eventually be revealed. Around 252 million years ago, Earth's biosphere faced a catastrophic event. Nearly 96% of marine fauna, about 70% of land vertebrates, and roughly 83% of insects perished in a geologically short period. The causes of this disaster remain unclear, but instead of wiping out life, it marked the beginning of a new era. Around 252 million years ago, the Earth witnessed the emergence of the most well-known prehistoric creatures, the dinosaurs. This significant event, known as the Permian-Triassic extinction, marked the beginning of the Mesozoic era, a new chapter in Earth's geological history. Lasting approximately 186 million years, this era played a crucial role in shaping the planet into its present form. During this time, a transformative tectonic process occurred, the breakup of the supercontinent Pangaea. It initially split into two land masses, Laurasia and Gondwana, eventually giving rise to the continents we recognize today. Overall mass. Despite having no magnetic field, observations suggest the metallic core is likely in a solid state, surrounded by a silicate mantle extending 3,000 kilometers deep. A solid crust with an average thickness of 16 kilometers tops the mantle. Venus's lithosphere doesn't form tectonic plates due to high temperatures and rock viscosity, resulting in geological activity different from Earth. Additionally, Venus is distinct for its scarcity of large impact craters. Large parts of Venus's surface are covered by basalt plains formed from solidified lava. Some unique Venusian features, not seen on other planets in the solar system, include tesserae, highly rugged mountainous areas resembling roof tiles. Arachnoids and coronae are two other distinctive types of Venus's terrain, featuring circular structures with diameters measuring several hundred kilometers. Although they might seem like impact craters, these formations originated from tectonic processes rather than celestial objects. For an untrained eye, Venus's terrain features may not be easily noticeable, even in processed images. To better understand, let's explore the elevation map of the planet's surface, where areas of different heights are highlighted with contrasting colors. The most prominent elevated feature on Venus is Aphrodite Terra, often considered a hypothetical continent. Stretching along the equator, Aphrodite Terra's mountainous relief is complex, with an estimated length of up to 18,000 kilometers and a width around 5,000 kilometers. Depending on how the continent's borders are defined, its area is estimated between 29 and 41 million square kilometers, comparable to Asia's size. Aphrodite Terra is divided into three vast regions: Alpha Regio, Beta Regio, and Gamma Regio. Alpha Regio, located in the eastern part, stands out for hosting Venus's highest volcano. The distance from its base to its summit is approximately 5 kilometers, with an overall height above the average surface level ranging from 8.3 to 8.8 kilometers. According to various estimates, the volcano is currently not active, although there is evidence suggesting it erupted relatively recently in geological terms. This evidence includes solidified lava flows and the absence of impact craters. The volcano, located on the slopes of Beta Regio in the western part of Aphrodite Terra, is particularly interesting due to its tectonic activity. The mountain ridges in this region run in different directions, indicating various forces acting on the crust simultaneously. Additionally, deep crevices containing traces of lava spillage have been discovered, making these among the most unusual volcanoes on Venus. Moving to the western edge of Aphrodite Terra, we find the alleged landing sites of 4 Venera probes. 2 of these probes were destroyed by the planet's atmosphere before reaching the surface. These sites are situated in the southern part of a vast lowland region known as Guinevere Planitia, which extends for thousands of kilometers, comparable in size to Aphrodite Terra. Despite being called a planitia, this area has diverse relief, including various geological formations. Tectonic forces crumpled the planet's crust for hundreds of millions of years, creating ridges and folds. Meanwhile, lava spilled from crevices, solidifying to form smooth basalt plains in the lowlands. As a result, Guinevere Planitia features both flat areas and distinct uplands. The western part of Guinevere Planitia borders Beta Regio, a bright and elevated area with a round shape, approximately 2,500 kilometers in diameter. The eastern part of Ishtar Terra is the resting place of the remains of the Venera 9 and Venera 10 spacecraft. These spacecraft provided us with the first photos of Venus in 1975, measured the atmosphere's properties, and collected soil samples similar to basalts on Earth. This data suggests that Beta Regio is Venus's largest volcanic massif, making it a promising area to search for active volcanoes. Moving northward, we reach the second largest hypothetical continent on Venus, called Ishtar Terra. It spans about 8,000 kilometers from east to west and approximately 2,500 kilometers from north to south, with a total area of around 8.5 million square kilometers, just slightly larger than Australia. In the center of Ishtar Terra lies the largest volcanic massif on Venus, Maxwell Montes, towering 11 kilometers above the planet's average surface level and 7 kilometers above the surrounding terrain. Maxwell Montes features a relatively flat plateau of approximately 200 by 400 kilometers around the highest peak. The height difference within this region is minimal, making it challenging to distinguish individual peaks accurately. Maxwell Montes is the coldest area on Venus, with temperatures around 380 degrees Celsius, and the atmosphere is about twice as rarefied as near the surface. Despite the harsh conditions, the region appears bright in photos, suggesting that the peaks and slopes may be covered with a reflective substance. Many parts of Venus's surface may be covered with metallic compounds containing impurities like pyrite, hematite, or galena. Exposed to high temperatures, these substances can vaporize from lowlands and then precipitate in colder mountainous regions, resembling fine-grained snow. As we explore the Venusian surface, The thought of these incredible and mysterious places remaining unexplored by humans comes to mind. Is there a chance for us to leave our footprints on this planet's surface, so close yet so forbidding? The atmospheric pressure on Venus is about 93 times that of Earth, and the average temperature near the surface is a scorching 737 Kelvin or 464 degrees Celsius. These extreme conditions make it challenging for space probes designed for Venus exploration, lasting no more than an hour. The idea of terraforming Venus seems unrealistic due to its harsh conditions. However, in the upper layers of Venus's atmosphere, there are some regions with temperatures and pressures closer to those of Earth. In the last century, there were even ideas about designing a habitable base floating in Venus's atmosphere, suspended from special aerostats. Yet, the practicality of implementing such projects remains uncertain. Whether or not humans will set foot on Venus, the planet awaits its heroes, and its secrets will eventually be revealed. Around 252 million years ago, Earth's biosphere faced a catastrophic event. Nearly 96% of marine fauna, about 70% of land vertebrates, and roughly 83% of insects perished in a geologically short period. The causes of this disaster remain unclear, but instead of wiping out life, it marked the beginning of a new era. Around 252 million years ago, the Earth witnessed the emergence of the most well-known prehistoric creatures, the dinosaurs. This significant event, known as the Permian-Triassic extinction, marked the beginning of the Mesozoic era, a new chapter in Earth's geological history. Lasting approximately 186 million years, this era played a crucial role in shaping the planet into its present form. During this time, a transformative tectonic process occurred, the breakup of the supercontinent Pangaea. It initially split into two land masses, Laurasia and Gondwana, eventually giving rise to the continents we recognize today. These continents featured large, independent territories separated by seas and straits, fostering the development of distinct ecosystems and driving new evolutionary adaptations. In terms of climate, the Mesozoic was the warmest era in the history of multicellular life forms. Throughout this period, there was no permanent ice shield, even at the poles. However, temperatures would fluctuate, challenging both plant and animal life to adapt to the changing conditions. The Mesozoic era is divided into three periods, with the first being the Triassic. Spanning around 51 million years, the Triassic was characterized by the early stages of tectonic processes breaking down Pangaea. During most of this period, Pangaea persisted, with the Ural Ridge completing its formation. The climate was relatively dry and hot, leading to the presence of numerous deserts and a reduction in the size of inland bodies of water. During most of the Triassic period, the air contained about 10 to 15% oxygen. However, approximately 215 million years ago, there was a sudden increase, reaching as much as 19%. The exact reasons for this change are not certain, but it is believed to be linked to the evolution and spread of specific varieties of marine or land plants. In the Triassic, prehistoric seed ferns were the dominant flora, but they were gradually replaced by more advanced plant groups like cycas, ginkgo, and prehistoric conifers. While these plant orders have survived to the present day, they are not as diverse as they once were. In marine environments, the oceans, which had been emptied by the Permian-Triassic extinction, saw the gradual emergence of turtles and teleosts. The first ichthyosaurs occupied the niche of large predators, although they were still relatively primitive at that time. An example is Symbospondylus, a giant sea saurian that lived 240 to 210 million years ago. It measured 6 to 10 meters in length, primarily ate fish. had a long, thin body with a flexible tail, and its limbs resembled diving fins. On land, the common representatives included rhynchosaurs, prehistoric ancestors of dinosaurs, crocodile-like amphibians called amphibamids, and early bird ancestors. By the middle of the period, the first dinosaurs evolved from ancient archosaurs, marking the beginning of their independent existence. However, they faced a challenging struggle for survival. It was only towards the end of the Triassic that dinosaurs began to establish dominance in Earth's biosphere. This coincided with an increase in oxygen levels and a significant growth in the size of these fascinating creatures. In today's world, with numerous movies and countless books featuring terrifying dinosaurs, everyone is familiar with their appearance. However, amidst these giants, there are other species equally important and interesting. Take, for instance, Oligochaphus, a small creature from the late Triassic period, around 200 million years ago. Oligochaphus, a member of the Cynodonts, a group of prehistoric animals distinct from mammals, was a small and nimble creature. With a thin, flexible body measuring around 50 centimeters, it resembled a weasel. Warm-blooded and herbivorous, Oligochaphus was found in the territories of North America, Europe, and China. While it's uncertain whether it had a pouch on its stomach, the structure of its skeleton suggests that its babies were small, similar to today's marsupials. It's also probable that Oligochaphus nursed its young with milk. There's speculation that these creatures dug burrows and took care of their babies, indicating a relatively high level of intelligence. Unfortunately, Oligochaphus became extinct at the beginning of the Jurassic period, possibly due to a lack of food and increased competition. Nevertheless, they remain among the oldest prehistoric animals resembling today's mammals. The Triassic-Jurassic mass extinction marked the end of the Triassic period, resulting in the disappearance of numerous amphibians, some archosaurs, reptiles, and many plant species. Potential causes for this disaster include volcanic activity, changes in global ocean levels, and sudden climate shifts. Regardless, this extinction event created vacant ecological niches, allowing dinosaurs to solidify their position in the Earth's evolutionary landscape. The next period in the Mesozoic era was the Jurassic, spanning from about 201 million years ago to approximately 145 million years ago, lasting around 56 million years. During this time, significant tectonic movements and transformations occurred. The Jurassic witnessed the final splitting of the supercontinent Pangaea into several land masses separated by shallow seas. Looking at the Earth map towards the end of the Jurassic period, one can identify the shapes of some present-day continents, although their positions may be unexpected. The newly formed continents were isolated, giving rise to distinct biosystems. As a result, certain animals and plants that thrived on one continent were absent on others. Throughout most of the Jurassic period, the Earth experienced a warm and humid climate, with a brief cooling towards its end. Large areas on land were covered by tropical forests, mainly consisting of cycads, palm-like gymnosperms, and widespread conifers resembling today's cypress and pine trees. The Jurassic marked a flourishing epoch for dinosaurs, showcasing a rich diversity that occupied various ecological niches. Dinosaurs, ranging from small saurians the size of a cat to massive herbivorous giants, known as sauropods, thrived. Prominent representatives included Brachiosaurus, Brontosaurus, Diplodocus, and others. The largest sauropod, Titanosaurus, measured up to 25 to 30 meters in length and could weigh over 75 tons. Sauropods, a unique group of dinosaurs, had a distinctive feature known as the sacral brain, a widening in the hind part of the vertebrae. This sacral cavity was believed to potentially contain 20 times more nervous tissue than the cranial brain. Current theories suggest that the sacral cavity may have held a glycogen body, providing additional nutrition for the nervous system of these giant dinosaurs. During the same period, various animal species were evolving, including mammals, reptiles, and arthropods. The oceans were teeming with bivalve mollusks, similar in many ways to their present-day descendants. Apex predators in the marine ecosystem included saurians like ichthyosaurs and plesiosaurs. Comparing different marine saurians, such as Ophthalmosaurus and Symbospondylus, reveals fascinating evolutionary changes. For instance, Symbospondylus, an ancestor, lived 140 to 210 million years ago, had a length of 6 to 10 meters, an elongated body, and a head less adapted to aquatic environments. On the other hand, Ophthalmosaurus, a descendant that lived 165 to 145 million years ago, had a streamlined body, a vertical tail well suited for aquatic life, and a dolphin-like appearance. Ophthalmosaurus, with its unique features, could breathe atmospheric air, stay submerged for around 20 minutes, reach speeds over 7 kilometers per hour, and dive as deep as 600 meters. Its diet primarily consisted of mollusks, including squid, and its eyes, protected by a bony sclerotic ring, allowed for effective vision in the dark, enhancing its capabilities for deep-sea hunting. The final period of the Mesozoic era is referred to as the Cretaceous. The Cretaceous period started 145 million years ago and lasted for about 79 million years, making it the longest phase in the Mesozoic era. During this time, the continents continued to drift apart. India separated from Africa and moved toward Asia, while South America also broke away, heading west. By the period's end, Africa, Australia, Greenland, North and South America took shapes similar to today, and Europe and Asia started to define distinct borders. The Cretaceous climate was initially relatively cool, warming somewhat between 100 to 85 million years ago before cooling persisted till the era's conclusion. This era is famous for dinosaurs like Tyrannosaurus and Triceratops, yet it's more noteworthy for the proliferation of flowering plants, trees, and eventually grasses. These plants formed turf, enhancing soil fertility, and their nutritious seeds became food for various species, driving the diversification of mammals and some herbivorous dinosaurs on a smaller scale. While reptiles dominated ecological niches, mammals continued to evolve, becoming more diverse. By the era's end, distinct mammal groups emerged, including congruids, Eulipotifla predators, and primates. Rapananamus, a mammal that lived around 125 million years ago, was one of the largest of its time, measuring up to 1 meter in length and weighing 12 to 14 kilograms. It might have looked like today's Tasmanian devils, with a predatory tooth structure but short, clumsy limbs, suggesting it may have been a scavenger. An interesting discovery in archaeological digs included Rapananamus's skeleton, with bits of a small dinosaur in its abdominal area. This could suggest that some mammals from that time hunted small dinosaur species like Psittacosaurus and Darchaeorates. Meanwhile, large aquatic saurians such as Ichthyosaurus, Plesiosaurus, and Mosasaurus had been dominating the seas. However, around 199.5 million years ago, their population sharply declined due to the extinction event caused by the second Elsianic anoxic event, which involved a significant decrease in oxygen levels in the ocean. One possible reason suggested is increased underwater volcanic activity. The Cretaceous was probably the coldest time in the Mesozoic, and all living creatures adapted to the dropping temperatures, including dinosaurs. Around 70 million years ago, the region now known as northern Alaska, above the Arctic Circle, was home to a unique dinosaur species called Nanooksaurus. Although distantly related to the giant Tyrannosaurus rex, Nanooksaurus was smaller in size. Its body measured around 6 meters, and it weighed just about 1,000 kilograms, approximately 8 to 9 times less than Tyrannosaurus rex. This size reduction is believed to be linked to a lack of available food in its habitats. Forced to survive in the challenging conditions of the far north, amidst snowy stretches and semi-darkness during the polar night, Nanooksaurus developed some unusual features. Firstly, it is likely that Nanooksaurus was warm-blooded, and its metabolic processes ran remarkably fast, similar to today's birds. Secondly, Nanooksaurus's body was covered with several layers of down and feathers, providing insulation to preserve warmth in the severe northern climate. This suggests that the northern saurian was probably an active and fast-moving predator. However, in the conditions of the polar night, traditional ways of hunting prey are not very effective. That's why it appears that Nanooksaurus had an exceptionally well-developed sense of smell and sensitive night vision. These assumptions are confirmed by the build of its cranium. Summers in northern latitudes were short and rather cool, so additional sources of warmth were needed for dinosaur eggs to ensure the proper development of the babies. Nanooksaurus is thought to have hatched its eggs and taken great care of the young ones. Studies of fossil finds show that the volume of the brain of this species was rather big, potentially making this dinosaur as intelligent as most of today's birds. Unfortunately, these evolutionary adaptations didn't save Nanooksaurus from extinction around 66 million years ago. The Cretaceous-Paleogene extinction event caused all non-avian dinosaurs to vanish from the Earth, along with marine saurians, pterosaurs, and many other species. Still, the terrifying saurians left their imprint in the history of our planet, and the ecological niches vacated by them were promptly occupied by birds and mammals. This marked the beginning of the Cenozoic era, with its highest being the unique creature known as Homo sapiens, the self-proclaimed king above all nature. Its evolution has only just started, and time will show what it has in store for this species. The Cretaceous-Paleogene mass extinction event heralded the beginning of a new geological era, the Cenozoic, which started 66 million years ago and is still ongoing. Throughout this period, the Earth's surface underwent global transformations and hosted a great multitude of amazing creatures. The first period in the new era was called the Paleogene, starting immediately after the disaster that wiped out dinosaurs and lasting for 43 million years. During this time, our planet underwent significant changes. India moved across the ocean and collided with the south coast of Asia, leading to the formation of the towering Himalayas. Additionally, Antarctica began developing its vast ice shield. In the initial 10 million years, Earth's biosphere recovered from the impactful changes, with new and agile animals, particularly mammals, quickly occupying the ecological niches left by the old masters. Life evolved, giving rise to diverse creatures such as the nimble Andrews arcus, the giant and robust Indricotherium, and the aquatic Archaeoceti, prehistoric ancestors of today's whales. While some of these fascinating creatures disappeared without a trace, others adapted to the evolving conditions. Around 23 million years ago, the Paleogene gave way to the Neogene, lasting approximately 20 million years and divided into two periods, with the longer one called the Miocene. This era witnessed a gradual and consistent cooling, with ice caps on Earth expanding, leading to cooler and drier climates. Global sea levels dropped, and mountain ranges like the Alps and the Andes rose higher. Consequently, the Mediterranean Sea was isolated from the global ocean, and nearly dried up, leaving extensive lowlands covered by salty deserts. In some regions, temperatures reached about 80 degrees Celsius, and atmospheric pressure at the basin's bottom was over 1.5 times the usual value. Only a few small lakes with extremely salty water remained in this barren and lifeless desert. During the Miocene epoch, Earth hosted a variety of peculiar creatures. The Gigantopithecus, an enormous man-like ape related to orangutans, stood over 3 meters tall and weighed up to half a ton, navigating dense Asian rainforests. Telodon, a bull-sized ungulate predator and scavenger, instilled fear among land dwellers. In the ocean, the depths were dominated by Megalodon, the largest carnivorous shark in Earth's history. A little over 5 million years ago, Gibraltar, known as the present-day area, experienced a massive earthquake. The rocky barrier that had separated the Mediterranean Sea from the Atlantic Ocean for hundreds of thousands of years finally collapsed. Millions of tons of water rushed into the vast, lifeless lowlands. The force of this flow, estimated to be 40,000 times that of Niagara Falls, filled up the sea again in just 2 years. Simultaneously, thick layers of sand and rock buried thousands of tons of salt, where it remains today. This significant event, known as the Zanclean Flood, marked the beginning of the Pliocene epoch, lasting for 2,745,000 years. During the early Pliocene, continents had settled into familiar positions, but certain geological features were still in the process of formation. For instance, North and South America were separated by a wide strait, and the Rocky Mountains were just beginning to rise. Earth's climate in the first half of the Pliocene was relatively warm, with an average temperature 2 to 3 degrees higher than today. However, this warmth wasn't distributed uniformly across the planet. While tropical latitudes resembled current conditions, northern areas experienced much warmer temperatures. The Arctic was not permanently covered in ice, and dense conifer forests extended to the northernmost regions of Eurasia. It's essential to note that during this time, the continent's borders were slightly farther south due to the sea level being, on average, 25 meters higher than today because of increased temperatures. Meanwhile, the earliest human ancestors, Ardipithecus, Sahelanthropus, and Orrorin, inhabited the African continent. The remains of these ancient primates date back 4 to 6 million years. While their body structure was still far from that of modern humans, these creatures mark the initial step in the evolution of a new life. The characteristics of their discovered skeletons indicate a shift towards an upright posture, although their tree-climbing habits were still evident. Despite these creatures clearly displaying traits of climbing trees, their cranial capacity was larger than that of chimpanzees, and their teeth structure resembled that of later species. What caused these ancient primates to undergo such significant changes? One potential reason is the collision of the continental plains of North and South America approximately 3 million years ago. This collision led to a rapid elevation of rocks, cutting off the straits between the continents with the formation of the Isthmus of Panama. This blocked the passage of warm ocean waters. Around the same time, the Rocky Mountains increased in height, creating a barrier between Atlantic and Pacific air currents. These factors collectively contributed to Earth gradually cooling, resulting in some parts becoming icebound. The North Pole developed an ice shield, and Greenland accumulated a substantial ice cap. Concurrently, the African forest diminished, making way for steppes and savannas. Although treetops provided great habitats, safe, comfortable, and abundant in food, global climate change led to the reduction of African forests. Many species lost their familiar habitats, causing them to disappear, while others had to adapt to survive in the new conditions. The savanna concept is currently the most developed and well-grounded hypothesis of anthropogenesis. According to this concept, the shortage of their usual food and the absence of wooded areas forced our ancestors out into the savanna, a terrain filled with unknown dangers. By this time, they were already capable of moving on two legs and using primitive tools. Like all man-like apes, these skills were crucial for survival in the new conditions. Easily digestible fruits and plants were scarce in the savanna, and rough grass and leaves were inedible for the primates. Tapping into animal sources of food became crucial for survival. However, one needed to be fast and strong to hunt successfully, which our ancestors lacked. Developing an upright posture was essential to give them an edge in these circumstances. Upright walking not only increased the speed of movement, but also allowed spotting both potential game and danger from afar. When the body is in a vertical position, strong hands with prehensile fingers are free, making it easier to use sticks or sharpen stones. By forming small tribes, the new inhabitants of the savanna could either hunt or take the kill from other predators by force. It is assumed that the necessity to coordinate actions in this process stimulated the development of the brain and primitive speech. Gradual evolution over several million years endowed the ape-like Ardipithecus and Sahelanthropus with human features. This led to the emergence of Australopithecus, an agile, smart, but not very large creature that appeared on the African territory from 4.2 to 1.8 million years ago. Currently, Mars is closely monitored by 8 automated space probes orbiting the planet. These probes have identified Olympus Mons, the largest volcano in the solar system, located in Mars's western hemisphere. Olympus Mons stands at an impressive 26 kilometers, approximately 2.5 times the height of Mount Everest. This shield volcano is believed to have formed from multiple layers of solidified lava. Unlike Earth, Mars lacks tectonic plates beneath its surface, allowing magma eruption points to remain fixed for extended periods, covering vast areas with layers of solidified lava, forming a rocky shield. Olympus Mons, the giant volcano on Mars, has an average diameter of about 600 kilometers, making it comparable to the size of countries like Poland or Italy. At its center, there's a massive depression with 6 calderas or collapsed volcanic craters. This depression is around 85 kilometers in diameter and 3 kilometers deep. The height of Olympus Mons is so remarkable that the atmospheric pressure at its top is 50 times lower than at the foot. Mars has a much thinner atmosphere than Earth, about 160 times more rarefied. The conditions at the summit are close to a vacuum, making it inhospitable for any visiting probes. The atmospheric density is too low for parachutes to be effective in slowing down a descending capsule with a Mars rover. While the average slope of Olympus Mons is gentle at only 5%, it has edges and almost sheer abysses reaching up to 7 kilometers high. The exact process that formed these enormous slopes is not certain, with some suggesting the influence of an ancient ocean on Mars or continuous sandstorms in the area. Moving away from Olympus Mons, the surroundings reveal overlapping ridges and isolated mountains, some extending up to 1,000 kilometers from the volcano's edge. These formations might have resulted from the erosion of the giant mountain slopes or the movements of ancient ice caps. Continuing southeast from Olympus Mons, we enter Tharsis, a vast volcanic upland covering about 1/4 of Mars's surface. Formed by solidified lava streams, Tharsis is 10 kilometers higher than the surrounding plains, and its age is estimated to be around 3.7 billion years. In this area, there are many volcanoes, some of them almost as big as Olympus Mons. For instance, Arsia Mons rises to about 19 kilometers, making it the second highest peak on Mars. It has a summit caldera that's 110 kilometers wide, and the overall diameter of the mountain is over 400 kilometers. A fascinating natural event occurs over Asia Mons each year. When the sun warms the mountain slopes, small dust spirals into a dense cloud carried by upward air streams. This cloud may float up to 30 kilometers above Asia Mons and scatter across large areas. Throughout the upland, there are vertical pits, some quite deep with unobservable bottoms. The largest pit has a diameter of about 150 meters, and its depth is at least 178 meters. These pits are believed to be collapsed lava tubes. Tharsis, where these volcanoes are located, consists of overlapping shield volcanoes. Over billions of years, these volcanoes released large amounts of CO2 and water vapor into the Martian atmosphere. Mathematical models suggest that this release could have created an atmosphere on Mars 1.5 times denser than Earth's in the past. This indicates that Mars might have had more favorable conditions for life to originate than it does now. However, due to its weak gravity, Mars lost its atmosphere over time. Heading east from Tharsis, we reach Valles Marineris, a network of massive canyons stretching up to 4,500 kilometers. The width of the canyon is 600 kilometers, and it's more than 11 kilometers deep. The slopes of most canyons in the central and western parts of Valles Marineris show a stratified structure similar to deposits at the bottom of a large body of water. It's likely that these canyons were once completely submerged underwater in the distant past, making them a valuable area for paleontological discoveries. The eastern part of Valles Marineris has a complex landscape with labyrinths of small canyons, abysses, mountains, and plateaus. Moving north, the terrain becomes a relatively smooth plain known as Utopia Planitia. This large area is where debris from the Sojourner Mars rover and the Viking 1 probe, which sent the first color images of Mars in 1976, can be found. According to the widely accepted hypothesis, Valles Marineris formed during the early stages of Mars's development due to erosion and geological processes that deepened and widened the canyons. One version suggests that volcanic eruptions on the Tharsis upland contributed to the formation of this canyon system. Another version proposes that Utopia Planitia, on the opposite side of the planet, could be responsible, possibly created by the impact of an extremely large asteroid. Utopia Planitia is a vast, round lowland with a diameter of approximately 3,300 kilometers. The surface is flat and smooth. Several space probes, including Viking 2 in 1979 and the Chinese rover Zhurong in 2021, have explored this region. The Charade radar on the MRO probe detected rich deposits of water ice mixed with dust underground in 2016. Despite extensive exploration, Zhurong can't dig deep enough to reach the water-carrying layer, located 1 to 10 meters below the surface. In the north, Utopia Planitia borders on the Planum Boreal, a giant lowland covering about 40% of Mars' total area. Heading southwest from the center of Utopia Planitia, we arrive at Icaria Planitia. The region's western edge has been under close observation for nearly 8 months, primarily focusing on the Jezero crater. It's believed that this crater used to hold water millions of years ago, and now the Perseverance Mars rover, along with the first ever helicopter on Mars, Ingenuity, has been exploring its bottom since February 18, 2021. Jezero crater was selected for the mission because it seemed promising for discovering traces of Martian life. Formed around 4 billion years ago by a massive celestial impact, the crater, with a diameter of about 49 kilometers, is thought to have once contained water during the Hesperian period, which started around 3.5 billion years ago, and lasted for about 1 billion years. During the Hesperian, Mars likely had an atmosphere similar to Earth's, with temperatures reaching 50 degrees Celsius. Recent rock samples extracted from the crater's bottom by the Perseverance rover provide strong evidence of past contact with liquid water. While these samples are yet to be transported to Earth for deeper analysis, it's clear that they hold valuable information. Perseverance continues to deliver significant data, and the mission, designed for 14 years of operation, is still ongoing, promising many more discoveries as it covers more Martian terrain. Our journey across Martian landscapes is far from complete. Let's dive into the asteroid belt, a fascinating and ever-changing region in our solar system. Currently, there are over 300,000 small celestial bodies identified here, each with names and numerical designations, and the total number could be well over 1 million. The exploration of the asteroid belt began in 1801 when astronomers spotted a mysterious object. Initially thought to be a planet due to its size, it turned out to be much smaller, appearing as a bright dot in the sky, and was named Ceres. Soon after, similar objects were discovered, and a new term, asteroids, was introduced to describe these star-like bodies. Aside from asteroids, the asteroid belt is filled with cosmic dust. As these tiny particles scatter sunlight, they create a faint glow known as zodiacal light. Interestingly, this glow can be seen with the naked eye in equatorial areas for an extended period. In the past, it was hypothesized that the objects in the asteroid belt were remnants of a destroyed planet. However, this idea doesn't quite fit today's understanding. Firstly, the total mass of all the objects in the asteroid belt is relatively small, just 4% of the mass of the Moon. Even considering that some asteroids might have left, it's still not enough to form a proper planet. Secondly, Jupiter's gravitational influence prevents the formation of large celestial objects in this region. Mathematical modeling indicates that the largest formations in the asteroid belt have never exceeded 1,000 kilometers in diameter. The gravitational pull of Jupiter, a powerful giant in our solar system, caused the orbits of potential protoplanets in the asteroid belt to become unstable. This instability led to collisions and the breakup of these celestial bodies into smaller fragments. We can still see traces of these collisions today. Many objects in the main asteroid belt group together to form what we call asteroid families. These groups share similar characteristics and likely originated from destructive collisions. The main asteroid belt's boundaries are not precisely defined, but most objects within it are found between 2.06 to 3.27 astronomical units from the Sun. Jupiter's tidal forces create gaps in this region, known as Kirkwood gaps, where celestial objects experience the strong gravitational influence of the gas giant, leading to destabilized orbits. The asteroid belt has two distinct regions, the inner and outer belts. A Kirkwood gap with a radius of 2.5 astronomical units separates them. One of the most prominent gaps lies around 2.82 astronomical units from the Sun. In the outer part of the main belt, we find Ceres, the largest object in this area. Ceres, once considered a planet, was later classified as a dwarf planet in 2006. It stands out because it has a spherical shape, unlike most other objects in the belt. Ceres has a diameter of about 940 kilometers and a mass of 9.4 times 10 to the power of 20 kilograms, contributing to approximately 1/3 of the asteroid belt's total mass. Despite its significance, Ceres is much lighter than Earth, weighing around 6,000 times less. The dwarf planet Ceres orbits the Sun, reaching its farthest point at 2.9 astronomical units. When closest to the Sun, perihelion, Ceres is about 2.5 astronomical units away. At perihelion, the surface temperature can drop to 33 degrees Celsius below zero, while the average temperature is even colder at 106 degrees Celsius below zero. Ceres is believed to have a rocky core surrounded by a cryomantle, approximately 100 kilometers thick, with water ice making up half its volume, or 20 to 30% of its mass. In the inner part of the asteroid belt, we find the largest and heaviest known asteroid, Vesta. Vesta has an average diameter of approximately 525 kilometers and a mass of around 2.6 times 10 to the power of 20 kilograms, which is nearly 4 times less than Ceres. Vesta's orbit is elongated, with an aphelion of 2.57 astronomical units and a perihelion of about 2.15 astronomical units. It takes Vesta 3.6 Earth years to complete one orbit around the Sun. Vesta is noteworthy for being the only asteroid visible to the naked eye due to its impressive size and light-reflecting surface, reflecting about 42% of light. Its minimum distance from Earth is 177 million kilometers, or 1.18 astronomical units. Vesta is considered similar to a fully fledged planet with a metallic core of nickel and iron and a rocky mantle. The asteroid's surface temperature currently ranges between -190 and -20 degrees Celsius. On Vesta's surface, dark areas in the western hemisphere, known as basalt plains, suggest volcanic activity or collisions with large celestial bodies in the past. The most prominent geological feature on Vesta is the massive impact crater named Rhea Silvia, with a diameter of up to 500 kilometers and a depth of around 25,000 meters. At its center, there is the second largest mountain in the solar system, rising over 22 kilometers high. The crater is quite impressive. Its diameter is almost the same as the size of the asteroid Vesta. It appears as though the asteroid collided with a very large object in the past. This collision not only created the Silvia crater, but also produced numerous small pieces that now form the Vesta family of asteroids. This asteroid family consists of over 15,000 objects, making up about 5% of all celestial bodies in the main belt known to science. Scientists posit that many asteroid families are the result of destructive collisions between large celestial objects. Sometimes the debris from these collisions is attracted to each other by gravity forces, forming new astronomical objects. However, these objects may lose their monolithic nature, and astronomers informally refer to such formations as rubble piles. Silvia, one of the largest objects in the asteroid belt, seems to fall into this category. It has dimensions of 384 by 262 by 232 kilometers and a mass of 1.5 times 10 to the power of 19 kilograms. The asteroid's average density is just 20% higher than that of water, with estimates suggesting that cavities may account for 25 to 60% of its volume. Silvia takes 6.5 years to complete a full orbit around the Sun. At its furthest point from the center of the system, it reaches up to 3.7 astronomical units, and at its closest, perihelion, it gets as close as 3.2 astronomical units to the Sun. After a collision, some debris may not be attracted to other pieces, but instead become satellites of the new celestial body. Silvia has two known companions, Romulus, with a diameter of 18 kilometers, and Remus, measuring around 7 kilometers. The composition of these companions hasn't been studied yet, and it's likely that these objects are not monolithic either. Additionally, Silvia may theoretically have smaller satellites that haven't been detected yet. Another noteworthy object in the asteroid belt is Pallas, discovered in 1802. It is the second largest asteroid in the belt, with an average diameter of around 512 kilometers and a mass of roughly 2 times 10 to the power of 20 kilograms, about 25% less than that of Vesta. The asteroid's path around the Sun is really stretched out and tilted at 35 degrees to the ecliptic plane. This makes it tough to study with probes. It takes the asteroid Pallas about 4.6 years to complete one orbit around the Sun. During this time, its distance from the center of the solar system changes a lot, going from 2.1 astronomical units at its closest, perihelion, to 3.4 astronomical units at its farthest, aphelion. Pallas's surface is full of craters, much more than the largest asteroid, Vesta. Studies of the asteroid's surface show that it's mostly made of silicate rocks with a bit of iron and water, similar to Vesta. Scientists think Pallas might be one of the few remaining protoplanets, and studying it could give us important info about how the solar system formed. Unlike Vesta, most asteroids can't be seen with the naked eye or through regular telescopes. One such mysterious asteroid is Interamnia, which is irregularly shaped and measures 362 by 348 by 310 kilometers. Its mass makes up about 1.2% of the total mass of all objects in the asteroid belt. Even though it's relatively big, Interamnia hasn't been studied much. One challenge is its dark surface, which absorbs about 93% of the light that hits it. Interamnia belongs to the rare spectral class F, a type of carbonaceous asteroid. Studies of its reflection show that its surface color is even, suggesting it hasn't experienced major collisions for a long time. Interamnia isn't very dense, just twice that of water, and scientists think it has a hard rocky core covered by a thick layer of ice. The surface is covered with a lot of fine, dark dust. It takes Interamnia about 5 years and 4 months to go all the way around the Sun. Its orbit is on the opposite side of the 4 biggest objects in the main asteroid belt. The distance from Interamnia to the Sun changes from 2.5 to 3.5 astronomical units. In theory, its orbit crosses the paths of big objects like Ceres and Pallas, but the chance of them colliding is small. There are millions of objects in the asteroid belt, from small planets to tiny meteoroids the size of a cobblestone. However, the distances between them are really big, thousands or even millions of kilometers. This means that a spacecraft passing through the belt has a very low chance of hitting anything. Still, mathematical models show that once every 10 million years or so, there are some rare collisions that create new debris. Even though a manned mission to the asteroids in the main belt won't happen for a while, some asteroids there have been studied using space probes. For example, the Dawn probe observed Ceres and Vesta from 2011 to 2016. Recently, the Lucy probe was sent into space. While its main goal is to study Jupiter's Trojans, it will also approach an object in the main belt called Donald Johanson and take pictures in 2025. Although asteroids are small, they're important for both science and practical reasons. Some asteroids in the main belt are like treasure chests, holding clues about how the solar system formed. Studying them helps us understand the processes behind the formation of planets and other celestial bodies. In the future, asteroids could provide materials for space exploration. We're not sure when we'll be ready for that, but every new rocket launched into space brings us a bit closer to the space era. For life to begin and evolve, a mix of many factors is needed. The main ones include having liquid water, an energy source, and various chemicals. Besides Earth, there are other places in our solar system where life could exist. Mars is the most likely candidate and has been studied a lot recently. However, there's a chance of finding alien life beyond Mars, especially if we look at the next closest planet to us, Jupiter. Jupiter is the biggest planet in our solar system, much larger than Earth. It's a gas giant, mostly made of hydrogen and helium. There are also other compounds like methane, ammonia, sulfur, nitrogen, and water ice in its atmosphere. However, the chance of finding life directly on Jupiter is very small. Jupiter doesn't have a solid surface, and its inner layers are extremely hot with unimaginable pressure, making it impossible for biological creatures to survive. But Jupiter has many moons, and 4 of them, Io, Callisto, Ganymede, and Europa, were discovered by Galileo Galilei in 1609. Although these moons are relatively close in size to Earth's moon and Mercury, finding life on them seems unlikely at first. They are far from the sun, covered in ice, and their atmospheres are not thick. However, upon closer examination, these moons show something exciting. Callisto, Europa, and Ganymede likely have liquid oceans under their icy surfaces. Scientists estimate that celestial objects with hidden oceans might provide suitable conditions for life, even if they are much farther from their star than Earth is from the sun. The thick, icy surface not only protects against radiation and meteorites, but also acts as good thermal insulation. So, while Jupiter itself may not be a host for life, its moons present an intriguing possibility for the search for extraterrestrial life. That's why it's possible that life could start and develop in a massive layer of water. These ideas make Jupiter's moons interesting for exploration in our solar system. Let's take a closer look at each of them. Ganymede is the biggest moon around Jupiter and one of the largest in our solar system. It stands out not only for its impressive size, but also because it's more like a real planet than other moons. Ganymede's radius is 2,634 kilometers, which is 8% more than Mercury's. Its mass is 1.48 times 10 to the power of 23 kilograms, twice the mass of our moon. What's fascinating is that Ganymede is the only moon with a liquid metal core and its own magnetosphere. Inside Ganymede, nuclear decay processes heat up the satellite even more. The average surface temperature is very cold at 110 Kelvin or 163 degrees Celsius below zero. However, the core can be as hot as up to 1500 to 700 Kelvin. Studies of Ganymede's magnetic field by the Galileo space probe suggest a multi-layer salty ocean under its icy surface, possibly as deep as 200 kilometers. There might be 4 layers with different salinity, density, and temperature, separated by some ice. Spectroscopic studies of Ganymede's surface reveal a thin oxygen atmosphere. But this doesn't prove there's life. Molecular oxygen forms when water ice is exposed to ultraviolet radiation and the lighter hydrogen escapes into space. The heavier oxygen stays close to the surface. Besides water ice, elements like carbon dioxide, sulfur dioxide, sulfates, and other organic substances are found on Ganymede's surface. They might have come from the subsurface ocean, but how they end up on the surface is still unclear. Callisto is another moon around Jupiter that could be interesting for life. This moon is the second largest one around Jupiter and is the farthest from the planet. It has a diameter of 4,820 kilometers, almost the same as Mercury. Callisto is covered by a thick icy shell, about 80 to 150 kilometers deep. There's a good chance that under this shell there's a hidden salty ocean with a lot of ammonia and other substances. Estimates suggest this ocean could be 50 to 300 kilometers deep, with a temperature around 251 Kelvin or 21 degrees Celsius below zero. According to most models, due to impurities and high pressure, the water in the ocean should stay in a liquid state. Below the subsurface ocean, there's likely a layer of ice about 300 kilometers thick, and the moon's core, made of water, ice, and rocks, is even deeper. Callisto's surface is full of craters. Spectral analysis, which studies the light reflected from the moon, shows water vapor, silicon rocks, ammonia, carbon dioxide, sulfur, iron, magnesium compounds, and complex organic polymers containing nitrogen. These colorful substances are formed on the surfaces of celestial bodies due to ultraviolet radiation. Callisto is too far from Jupiter to get much heat from it, and the tidal influence from Jupiter isn't strong enough to deform the moon. Even though there might be some heating due to friction, most of these icy bodies are preferred to be solid rocks to provide the necessary elements for life. However, with the limited chemical diversity and low temperatures on Callisto, the chances of life evolving there are not high. But of course, we shouldn't completely rule out this possibility. The most promising moon around Jupiter for searching for alien life is Europa, the smallest of Jupiter's 4 Galilean moons. It's just a bit smaller than our moon, and the temperature on its surface is very cold, at 110 Kelvin or 163 degrees Celsius below zero. On Europa, temperatures can get as low as 50 Kelvin or 223 degrees Celsius below zero. Europa always shows the same side to Jupiter, but its rotation is not perfectly synchronized. There are some deviations from the expected path, suggesting there might be a liquid layer between Europa's surface and its core. Observations by the Galileo space probe in the late 20th century, looking at how Europa interacts with Jupiter's magnetic field, support this idea. Analyzing the cracks on Europa's surface reveals that the crust has moved 80 degrees compared to the interior. This movement wouldn't be possible without a liquid layer between them. Jupiter's strong gravitational influence causes powerful tidal waves in Europa's subsurface ocean, heating the moon even more due to internal friction. Estimates suggest that the temperature inside Europa is high enough for a liquid water ocean, possibly reaching a depth of 100 kilometers with a volume twice that of Earth's global ocean. Europa's surface is covered by a smooth and clear layer of ice. The highest features rise just a few hundred meters above the surface, and the icy crust may be 10 to 30 kilometers thick. This ice provides valuable material to study Europa's interior. Another interesting aspect is the presence of powerful ice-celled vapor geysers that only open when Europa is farthest from Jupiter. These geysers can reach heights of up to 200 kilometers and are made of unexpectedly clean water vapor. It's not yet clear whether these geysers are linked to Europa's interior ocean or if they originate from large lakes within the moon's icy crust. Scientists estimate the composition of Europa's subsurface ocean by analyzing the ice in the inner part of its largest craters. Only a really big object can break through the thick layer of ice on Europa when it crashes into it. After the ice crust breaks, the water in the subsurface ocean at the impact site freezes and forms the bottom of a crater. Analyzing these craters shows magnesium, sulfur, iron compounds, hydrogen peroxide, and strong acids. This tells us that there is a wide variety of minerals in Europa's hidden ocean. Europa's atmosphere has oxygen, which forms when ultraviolet radiation interacts with ice water on its surface, splitting the water into oxygen and hydrogen. However, Europa's atmosphere is about 1 trillion times less dense than Earth's. Still, some estimates suggest that there could be enough oxygen in Europa's subsurface ocean to support single-cell aerobic life forms. Underwater volcanoes could be their sources of energy and food, saturating the water with sulfur and dioxide. Primitive organisms might attach themselves to the bottom of the ice crust or swim freely in the water. Some thought there could be primitive multicellular organisms in Europa's ocean, but this idea seems too presumptuous. On Earth, many species can survive in conditions similar to Europa's subsurface ocean. including bacteria and multicellular creatures like tardigrades. So, it's possible that primitive life could exist in the depths of Europa on its own. Unfortunately, despite our keen interest in Jupiter and its moons, we've only briefly studied them with passing spacecraft. There have been no attempts to land on the gas giant's moons. Currently, the Juno probe is investigating Jupiter, but in July 2021, it will move on to study the Galilean moons. The information gathered by Juno will be very important and help us understand what's happening in Jupiter's system. Looking ahead to future missions, in 2012, the European Space Agency started working on the JUICE project, which stands for Jupiter Icy Moon Explorer. The goal of this project is to explore Jupiter and its moons, Ganymede, Europa, and Callisto, in detail. JUICE is set to launch next year and reach Jupiter in early 2029. The mission is planned until 2033, and if everything goes well, it will significantly increase our knowledge about Jupiter and its moons. Another significant project is NASA's Europa Clipper, an automated probe set to launch no later than 2023 and reach Jupiter's system in 2032. Europa is the main focus of this mission, unlike JUICE, which covers multiple celestial bodies. About 100 million years ago, a large icy moon got too close to Saturn. The powerful tidal forces of the gas giant broke it into trillions of small pieces, forming what we now know as Saturn's rings. This moon, named Phoebe, was about 1,000 times more massive than Saturn's current rings. Over millions of years, some fragments of Phoebe were absorbed by Saturn, while others collided with its moons or left Saturn's surroundings. This scientific explanation is one of the most well-supported hypotheses for the origin and evolution of Saturn's rings. Even after hundreds of years of looking, there's still a lot we don't know about Saturn's rings, a huge structure in space. The rings don't have a clear border, and the part we can see is about 280,000 kilometers wide. But beyond what we can see, the whole structure's diameter is even more massive, reaching 16 million kilometers, although we can't see it from Earth because it's very spread out. Despite their impressive size, the total mass of the ring system is relatively small in space terms, estimated at 3 times 10 to the power of 19 kilograms. This is about 2,000 times lighter than the Moon. Only about 3% of the structure's volume is made up of solid objects, while the rest is filled with rarefied gas and cosmic dust. When we look at Saturn's rings through a powerful telescope, we see that they're divided into several large rings. Each of these rings is made up of many thin circles separated by narrow gaps. These gaps are formed because of the gravitational influence of Saturn itself and its many satellites. Some of these gaps are quite wide, reaching several hundred kilometers. Even though Saturn's rings reflect more sunlight than the planet itself, some rings are difficult to see. For example, the closest ring to the planet, called the D ring, is made up of tiny water ice crystals and frozen methane. Its upper border is thought to be about 16,500 kilometers above the planet's surface. There's no clear border on the inner part of the ring, and it gradually merges with Saturn's atmosphere. Next to it is the brighter and more massive C ring, which is about 17,500 kilometers wide. It's made up of small objects, each about 2 meters in size, making up just 0.033% of the ring's overall mass. The brightest and most prominent part of the rings is further out and is called the B ring. Starting about 34,000 kilometers above Saturn's surface and reaching 25,000 kilometers wide, the main part of the ring is not very thick, measuring only 5 to 10 meters. Its outer part forms a tall rim, standing up to 2.5 kilometers high. the outermost visible ring of Saturn, begins about 64,000 kilometers above the planet's surface. It is roughly 14,600 kilometers wide and contains not only relatively large ice pieces of 10 meters or more, but also some satellites like Pan, Daphnis, and others. The existence of these large objects might support the theory of new formation after the destruction of an ice satellite. Alternatively, they could have formed later as a result of smaller fragments colliding and merging. Beyond this part of the ring, there are the less noticeable F, G, and D rings formed from cosmic dust and rarefied gas. Most of Saturn's large satellites actively interact with the rings, traveling as far as 179,000 kilometers away to the region of the so-called E-ring. One of these satellites is Enceladus, with a diameter of just 500 kilometers. Although it's not one of the gas giant's largest satellites, it stands out because of clear signs of cryovolcanic activity. Analysis of observed emissions suggests the presence of liquid water beneath its surface. Mathematical modeling indicates that the temperature of Enceladus ranges from 45 degrees Celsius below zero in the upper layers to 0 degrees at the bottom. Due to a high content of dissolved salts and ammonia, the ocean doesn't freeze even in sub-zero temperatures, thanks to the 2-kilometer thick icy shield covering and insulating it. The surface of Enceladus is extremely cold, about 75 Kelvin or 198 degrees Celsius below zero. Its atmosphere is very thin and mostly made up of water vapor, nitrogen, carbon dioxide, and methane. Geysers erupt periodically through cracks in the icy crust, supplying the atmosphere with various elements. However, because Enceladus has weak gravity, its atmosphere tends to float away into space. The upper part of the atmosphere constantly loses particles, contributing to the E-ring around Saturn. On the other hand, Enceladus captures material from space, maintaining its unique chemical balance. The activity of Enceladus's geysers depends on its orbital movement, likely influenced by Saturn's tidal forces. These forces deform the icy shield of the satellite, causing cracks and eruptions. The cryogeysers' emissions contain complex organic molecules, suggesting that conditions in the subsurface ocean might be suitable for the genesis of biological life. Tethys, Saturn's fifth largest and most massive moon, is about 300,000 kilometers away. It shares its orbit with two other moons, Telesto and Calypso, located at stable Lagrange points. Unlike Tethys, these moons are smaller, measuring roughly 20 to 30 kilometers in diameter, with a total mass that's modest by space standards. Tethys itself has a diameter of about 1,060 kilometers, mainly composed of water ice with some rocky impurities. One notable feature on Tethys is the massive Odysseus impact crater, with a diameter of about 450 kilometers, about half the size of Tethys itself. The crater is 3 kilometers deep. Another distinct feature is the Ithaca Chasm, an enormous trench on the surface that stretches about 2,000 kilometers, roughly 1/3 of the Moon's circumference. It is up to 100 kilometers wide and has depths ranging from 3,000 to 5,000 meters, marked by craters and irregularities. One theory suggests the chasm formed as Tethys's subsurface ocean froze and expanded, while another links it to the impact that formed the Odysseus crater. Moving farther from Saturn, we find Titan, Saturn's largest moon and the second largest moon in the solar system after Ganymede. With a diameter of 5,152 kilometers, Titan is 5.5% larger than Mercury. Titan stands out as the only moon in our solar system with a dense atmosphere and liquid bodies on its surface. Despite its relatively small mass, Titan supports an atmosphere 1.5 times denser than Earth's. The atmosphere is primarily composed of nitrogen, over 98%, along with methane and other gases. Titan's low temperature, around 94 Kelvin or 180 degrees Celsius below zero, is due to its distance from the Sun. The Moon's atmosphere undergoes complex transformations, with nitrogen and hydrocarbon compounds exposed to solar wind turning into more intricate organic substances that settle on Titan's surface, hidden beneath an impermeable hydrocarbon smog. The surface of Titan cannot be seen in the optical range. According to the most likely model, Titan has a massive rocky core at its center, measuring about 3,400 kilometers in diameter. This core is surrounded by a thick layer of exceptionally dense ice, forming the base of a cool, salty ocean containing up to 10% dissolved ammonia. Above this ocean is a crust of water, ice mixed with methane hydrate, several kilometers thick. In the extremely low temperatures, the ice behaves like a solid, creating mountain ridges and elevations on the surface. The lowlands and chasms are filled with lakes of liquid ethane and other hydrocarbons. Titan constantly loses its atmosphere due to solar wind and Saturn's powerful magnetic field. However, internal processes continually replenish the atmosphere, and the loss may take billions of years. When the Sun enters its red giant phase, it could vaporize the hydrocarbon haze and melt Titan's eternal ices, making it a more favorable place for the genesis of life. But this change is still a long way off. Moving beyond Saturn's system, we find Pluto, situated about 40 astronomical units away from the Sun. It appears as a dark and indistinguishable object. Pluto follows an elongated orbit, completing it every 248 Earth years. With a radius of 1,188 kilometers, Pluto is smaller than all the planets in the solar system and some of their satellites, including the Moon. Despite its small size, Pluto's mass is accurately calculated to be 1.3 times 10 to the power of 22 kilograms, which is 1/18 of the lunar mass. Due to its characteristics, Pluto was classified as a dwarf planet in 2006, sharing similarities with other small celestial bodies like Eris, Ceres, or Sedna. Pluto has a long orbit, and in 1989 it reached its closest point to the Sun, known as perihelion, coming as close as 29.7 astronomical units. Since then, its distance from the Sun has been continuously increasing and will reach its farthest point, or aphelion, in 2113 at 49.3 astronomical units. Pluto is a distant and dim space object, making it impossible to see from Earth with the naked eye or even with the Hubble Space Telescope, where it appears as a murky brown disk without surface details. To study Pluto better, the New Horizons unmanned orbital station was sent in 2006. After a long journey of 9.5 years, it reached Pluto in 2015. During the flyby, New Horizons made about 400 observations, collecting over 6 gigabytes of information. However, the probe's trajectory did not allow it to photograph the entire surface of Pluto, as it didn't enter into orbit, but circled around it to explore other space objects. Before delving into Pluto's terrain features, let's understand its internal structure. According to the current model, Pluto has a massive core with a diameter of about 1,700 kilometers, composed of a mix of various forms of water ice and rocks. This core is surrounded by a 300-kilometer ice mantle, possibly undergoing tectonic processes that are not well studied. The mantle is covered by a crust made up of crystallized gases like nitrogen, methane, and carbon monoxide. Some assumptions suggest that Pluto's core may generate enough heat to melt parts of the icy mantle, potentially hiding a salty and toxic ocean deep beneath the surface, containing large amounts of dissolved ammonia. Pluto's surface temperature is extremely low, not exceeding 60 Kelvin or 213 degrees Celsius below zero. Our exploration of Pluto begins with its most notable feature, Tombor Regio. This vast region, situated in the equatorial zone of Pluto, is shaped like a heart, earning it the nickname the Heart. It spans 2,300 kilometers, covering about a quarter of the celestial body's total area. Tombor Regio's surface is not uniform. It includes a smooth and bright plain in its western part, known as Sputnik Planitia, measuring 1,492 kilometers in diameter. An elevation map reveals Sputnik Planitia as a large lowland area covered with a thick layer of nitrogen ice, along with carbon monoxide and solid methane. These substances, having a light color, result in some areas reflecting up to 90% of the incoming light. The region shows few craters, indicating its relative youth in geological terms. According to the main hypothesis, Sputnik Planitia formed around 100 million years ago, due to a collision with a large celestial body. This impact created a massive crater filled with contents from Pluto's hypothetical inner ocean, which quickly froze. Several features on the plain support this hypothesis. Smooth surface areas, ranging from 20 to 30 kilometers in size, exhibit hills and depressions concentrated along their borders, resembling convection cells found in fluids heated from below. This provides indirect confirmation of Pluto's warm interior. Tombor Regio is surrounded by relatively high mountain ridges, with Hilary Montes to the west of Sputnik Planitia reaching heights of 3.5 kilometers. In the southern part of the heart, Townshend Montes includes some peaks towering over 6 kilometers above Pluto's average surface level. Remarkably, these rocks are likely composed mostly of water ice, which, in Pluto's frigid temperatures, behaves as solid as rock. Heading a bit south, we come across a deep basin surrounded by massive layers of ice and rock, suggesting it might be the vent of an ancient cryovolcano. The rocks around it are believed to be frozen eruptions, and understanding their chemical composition is crucial for studying Pluto's inner makeup. The eastern part of Tombor Regio is darker and more cratered, indicating its greater age compared to Sputnik Planitia. Continuing east along the equator, we encounter a chain of dark spots called maculas, each hundreds of kilometers in diameter. Named after dark deities from various cultures, these maculas collectively form a structure known as the brass knuckles, stretching along Pluto's equator. Separated by high mountain ranges and cut by deep crevices, Cthulhu Macula is the largest dark spot, measuring almost 3,000 kilometers. Reflecting only about 30% of the light, Cthulhu Macula contrasts sharply with the bright Sputnik Planitia. While the exact nature of maculas remains uncertain, their dark color is thought to result from a high concentration of tholins and numerous impact craters, indicating their considerable age. Leaving Cthulhu Macula behind, we move north to Lowell Regio, a vast valley surrounding Pluto's north pole. Surprisingly, this area is currently the most illuminated part of Pluto's surface. Pluto's significant axial tilt means its north pole faces the sun during its movement, likely contributing to the tripling of atmospheric density over the past 30 years. The assumption is that the sun's rays evaporate nitrogen ice, which then settles at the pole, entering Pluto's atmosphere as it orbits. Pluto has some unique characteristics compared to other planets in our solar system. Besides its noticeable orbit tilt, the dwarf planet itself undergoes cyclic oscillations around a certain point, influenced by its large satellite named Charon. Charon's mass is 1.52 times 10 to the power of 21 kilograms, making up more than 11% of Pluto's mass. Both Pluto and Charon are tidally locked, always showing the same sides to each other. Charon has a darker surface with an abundance of water ice, mixed with methane and nitrogen in some regions. Pluto also has smaller, irregularly shaped moons, including Nix and Hydra, discovered in 2005, which are several tens of kilometers in size, and Kerberos and Styx, discovered later, with diameters not exceeding 16 kilometers. These moons, likely captured by Pluto's gravity from the Kuiper belt, were not fully captured by the New Horizons probe's cameras. One notable feature on Charon's visible surface is a vast region called Vulcan Planum, covering an area of at least 400,000 square kilometers. To the south of the equator lies the highest peak on Charon, Kubrick Mons, with a diameter of around 40 kilometers and an estimated height of 4,000 meters. Some theories suggest Kubrick Mons may be a cryovolcano where icy material rises from an underground reservoir. To the north, there is the expansive Oz Terra, marked with many craters and separated from Vulcan Planum by a system of giant ledges and crevices. While New Horizons didn't capture the entire surface of Charon, the visible features provide insights into the intriguing characteristics of this distant celestial body. The largest chasms on Pluto, like Serenity Chasma, have a total height of about a kilometer. Serenity Chasma, spanning 200 kilometers in length and varying from 40 to 50 kilometers in width, can be as deep as 7 kilometers. Exploring its bottom is challenging due to the thick shadows from the steep slopes. Moving further north, near the pole, there's the giant Mordor Macula, with a diameter of 475 kilometers. Its origin is still debated, with the current hypothesis suggesting that nitrogen and methane from Pluto's atmosphere were trapped by Charon's gravity, settling at its poles. After exposure to ultraviolet radiation, they turned into tholins, gradually concentrating in the ice. Research on Charon is just beginning, and there's much to learn. The Pluto-Charon system is fascinating, but not fully understood. The New Horizons probe, which explored these celestial bodies, left their vicinity, and they are moving away from us, taking their secrets along. Currently over 50 astronomical units away from Earth, the probe will continue beaming important data until about 2030, when its systems will eventually fail, leaving it alone in space. Around half a year before this video was posted on April 15, 2021, New Horizons became the 5th spacecraft to surpass 50 astronomical units from the Sun. Previous probes like Pioneer 10 and Pioneer 11 had achieved this milestone. New Horizons, launched on January 19, 2006, with a main goal to explore Pluto and Charon, successfully completed its mission. As with other space probes, it performed a gravity assist maneuver near Jupiter before reaching its destination. The spacecraft got a big speed boost and captured high-quality images of Jupiter and its moons during a gravity boost. The cameras on the probe even recorded the first-ever video of a volcano erupting on Jupiter's moon, Io. After this boost, the probe headed towards its main target, Pluto, reaching it in January 2015. The primary mission aimed to explore Pluto and Charon comprehensively. This involved taking pictures, mapping surfaces, estimating magnetic fields, studying solar wind activity, and collecting data on atmospheres and surface reflection properties. The program also searched for undiscovered satellites around Pluto and measured its orbital parameters more accurately. Even after completing the main mission, the probe remained useful. It went beyond Pluto's orbit, exploring objects in the Kuiper belt and capturing images of Kuiper belt objects like Quaoar 1 and Arrokoth. However, the radioisotope generator on the spacecraft is expected to run low from 2026, and its instruments will gradually turn off. New Horizons will continue its journey beyond the solar system, reaching a distance of 100 astronomical units from the Sun by 2038. At that point, the energy generator will stop working completely and any connection with the probe will be lost. This pattern occurred with two other probes, Pioneer 10 and Pioneer 11. They embarked on a journey out of the solar system a while back, becoming the first ever automatic space probes sent into interstellar space by humans. Pioneer 10 started its mission on March 3, 1972, and is currently 127 astronomical units away from Earth, moving at approximately 12 kilometers per second or 2.5 astronomical units per year. Its primary goal was Jupiter, and the mission was successfully completed, although the spacecraft is now not operational. Pioneer 10 reached Jupiter's system on December 4, 1973, after a 641-day journey through space. During the mission, it sent back images of Jupiter's surface and its largest satellites, providing valuable data on the planet's atmospheric composition and magnetic field. Additionally, it revealed that Jupiter emits 2.5 times more thermal energy than it receives from the Sun. This unique data laid the foundation for understanding gas giants and their satellites. The trajectory of the second probe, Pioneer 11, also included Jupiter, but its main target was Saturn. The scientific instruments on Pioneer 11 measured Saturn's magnetic field, and its cameras captured images of the gas giant, its rings, and two satellites, Titan and Mimas. The current distance between Pioneer 11 and the center of our system is estimated to be around 106 astronomical units. After completing their main missions, both probes continued their journey, moving farther away from the Sun. Unfortunately, they are now out of range, with the last signal from Pioneer 10 received in 2003 and the last signal from Pioneer 11 received in 1995. Both of them are currently speeding away from the solar system, with no chance of catching up with the next two probes we'll discuss. The Pioneers, launched much earlier, paved the way for exploration. Voyager 1, launched on September 5, 1977, is now 154 astronomical units away from Earth, moving at approximately 17 kilometers per second or 3.6 astronomical units per year. Its primary goals were Jupiter and Saturn, and the mission was successfully completed, although the spacecraft is not fully operational. Voyager 1 made significant contributions to our understanding of the solar system. It discovered new satellites around Jupiter and revealed details about its ring system. The probe's cameras captured volcanic eruptions on Io and provided evidence of Jupiter's Great Red Spot being a massive storm. After crossing Neptune's orbit, Voyager 1 sent back valuable data about interstellar plasma. Having left the Kuiper Belt and the heliopause behind, Voyager 1 is now rapidly crossing the solar system's scattered disk, heading towards the inner boundary of the hypothetical Oort cloud. It holds the title of the farthest man-made object in space and the fastest spacecraft on its way out of our system. Being the first to travel this far, Voyager 1 offers scientists a unique chance to study the heliopause, the region where solar wind pressure and interstellar gas pressure balance. Unfortunately, by around the year 2025, the power of the radioisotope thermoelectric generators on board the probe will run out completely and the connection will be lost. In 300 years, Voyager 1 is expected to reach the inner boundary of the hypothetical Oort cloud. It will then need around 30,000 years to pass through it completely. Afterward, about 10,000 years later, the probe will travel beyond the solar system's boundaries. It will have a close encounter with the star Gliese 445, passing at a distance of 1.6 light-years, before eventually getting lost in the vast expanse of outer space. Speaking of Voyager 1, we can't forget its twin launched from Earth on August 20, 1977. Voyager 2 had Saturn, Uranus, and Neptune as its targets, but it also approached Jupiter for a gravity boost. The images taken by this probe allowed scientists to suggest the presence of subsurface oceans on Ganymede and Europa. Upon reaching Saturn, Voyager 2 measured the gas giant's temperature and magnetic field, discovering several new satellites. The probe then continued to Uranus and Neptune, capturing unique snapshots and discovering 17 new satellites around these two planets. Both Uranus and Neptune were found to have ring systems. Under Neptune's gravitational influence, Voyager 2 changed its trajectory, moving away from the ecliptic plane. While it couldn't approach other objects in the solar system, the probe still had exciting goals ahead. It aimed to collect valuable data about interstellar plasma, cosmic wind, measure distances to stars, and explore the heliosphere. Currently, the probe is 128 astronomical units away from the solar system's center, traveling at 15.37 kilometers per second. It's expected to take around 42,000 years for Voyager 2 to approach Ross 248, a dim red dwarf in the constellation Andromeda. The closest distance between Voyager 2 and the star will be about 1.7 light-years, and approximately 300,000 years after its launch. It might fly by Sirius at a distance of 4.3 light-years. Unfortunately, it's impossible to spot such a tiny object from Earth at that great distance. We're in the early days of space exploration, and interplanetary space probes mark humanity's initial, cautious steps into the vast universe. Predicting their fate is challenging. They might collide with celestial bodies or be caught by our future advanced descendants with stellar travel technologies. Possibly, they'll be retrieved and displayed in a museum. However, it's more likely these delicate devices are destined to drift through the lifeless expanses for years. Millions of years later, radioactive rays and cosmic dust particles will wear them down to threadbare debris scattered across the universe without a trace. Our galaxy, the Milky Way, hosts at least 200 billion stars, some without planetary systems, while others rival our Sun in the diversity of orbiting bodies. There are over 1 trillion planets awaiting discovery in the depth of the Milky Way. This means our journey is just beginning, and your support is a powerful motivation for it to continue, leading us to the remotest worlds. Thank you for watching, and subscribe to learn more about the vast universe and its deep secrets. See you in the next one.